Let's do this. I think that's right. Okay, so problem number 8. We've got a graph. Huh? It's going. I can see it from here. I turned the camera. Alright, so we have this graph, and it's going from 1936 up to 2004. And we need to start collecting the data. And the way we're going to collect the data is by creating a stem and leaf chart. So we're looking at this piece right here, and each dot is going to be collected. Can you toss me a sock? Not your sock. It's gross. It's up there in the middle. Thank you, sir.
There's a sock right there.
I know, but that's so far. I can't bend over. Alright.
Only at the end of the day.
Now I'm not in the frame, but what I'm going to do is start collecting these points. And I don't need to really worry about this, because the data points that I'm collecting is I'm thinking about the metals, or how many metals were won in this case. Okay, so when we do it, we're going to do what's called a stem and leaf chart. And so I'm going to start at the lowest value, which is a 2, right? And so we have 1, 2. It's right here. I draw on it, but then I couldn't get it off. And then I go up and I look at a 4, and I have 4 4s, right? So I have a 4 and a 4 and a 4 and a 4. So now I'm going to bring the camera over to where I'm actually writing. And it should start to pick up what we're doing. So now we got the 2 and the 4 4s. And then we look at the 5s, and it has 3 5s, right? So we have a 5 and a 5 and a 5. And then we look for 6s, and we have 1 6, right? And then we have 2 8s. So I'm going to start with an 8 and go to 8. And then we have a 12, a 15, 19, 20, and 22. Now, generally, the way this would be written is in 0s and 1s, or 0s, 1s, and 2s. So a way to look at this would be 22, 20, 19, 12, and then the 8, the 0 column would be 8, and there's 2 8s, and then 1 6, and 3 5s, and 4 4s, and 1 2. Okay, and so this is the way you would write it in a typical stem and leaf plot. The reason why I wrote it down here was just so we could see this generalization. And this is what we call a right tail curve. Okay, and a right tail curve is what we're going to use in statistics. And what it shows is that the bulk of your information is actually on the left, right? And so, like I said earlier, some of my classes, hint, nudge, would look like this, right? As you're saying, these are your A's to F's, right? And then some of them, I'm not naming any names, oh, sorry, I had to sneeze, would be what we call a left tail curve, and it would look like this, and you'd have mostly F's, where very, very, very few A's. Like, so,
I'm showing you my grades right now.
so we're just kind of, sorry about the sneezing, I got a little sneeze attack going on. But, so going back to this, we want to talk about a few things. One is the mean, the median, and the mode, right? And so with this, we can see the mean, or the mode and the median really easy, right? So which one? What was the mode again on this?
The most.
The most, right? So 4, right? So it's pretty easy. Either way you look at it, the most comes up pretty easily. And so we know that the most is the mode, which is equal to 4, right? And then we have the median, right? The middle number. Okay, and that's the man. Oh, that was so close. Okay. The median. Who's got their phone on? Can you please turn that off? Okay, thank you. Alright, so the median number, right, is what?
5.5.
Goodness.
Oh, that's the middle number.
Huh?
Is it MEDIAN?
There we go. I'm like, what the hell? Heck. Okay. Alright, so the median number we're going to look at, and the easy way to do this is to go like this. But then when you hit these 4, you have to knock off 4 over here. Right? And then if you knock 3 off, you'll realize that there's really only 3 here. So you have these 3, and you have these 3. So in essence, your median is going to be made up of these 2. So it's actually going to equal the difference between 5 and 6. So you can't have 2 numbers. So we find the mean of those 2 numbers. And the mean is basically adding the 2 numbers up and dividing by 2. And you get the median is equal to 5.5. Alright? So we have the mode at 4. We have the median at 5.5. And then we want to think about the mean, right? And to do the mean, do you remember how to do the mean? Anyone?
You add them all up and then divide them.
Yeah, the mean is the tough one, right? So that's the sum of the numbers divided by the total number of numbers. It's kind of weird. So I'm just going to take all the numbers, 2 plus 4, instead of 4, 4, 4, 4, I'm just going to say 4 times 4, plus 3 times 5, plus 6, plus 2 times 8, plus 12, plus 15, plus 19, plus 20, plus 22, right? And it's all divided by however many numbers there are. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 numbers, okay? And so we'll take those numbers, and we've got 2 plus 4 times 4 is 16, plus 15 is 3 times 5, plus 6, plus 16 is 2 times 8, plus 12, plus 15, plus 19, plus 20, plus 22 equals. And so we get 143. So the mean equal to 143 over 16, right? And we get 8.9375. And so we usually round that off to the nearest tenth, okay? So we get our final answer. The mean is equal to 8.9, all right? Because the 3 won't move this up, it's not big enough, right? So it has to be a 5 or bigger. and then that would have got moved. So if that would have been 8.95, that would have been changed to a 9.0, because you always want to keep that significant figure, okay? The last decimal that you're rounding off to. And this lets you know that this last decimal was a 5 or more, okay? All right, so don't worry about that. This is your number we're dealing with. And that's how you would find the mean and all that. With that said, right? Now I want to go back to this great picture. And I want to talk about how we're going to find the slopes, right? And so with the slopes, we're looking at how does it rise from one to another, and how is that different? And so we can talk about, I'm here and I'm going to head over to my buddy's house, right? Or I'm here and I'm going to the Tacoma Mall. Or I'm here and I'm going to Seattle. I'm in Tacoma, I'm heading to Seattle. Or you can talk about any situation you want, right? You can talk about heart rates, right? So my heart rate is going up, then it went down. So what happened when my heart rate was going down, right? So I calmed down, right? I sat down maybe I meditated and brought it way down. Then I just started walking around and started coming up and down, right? These are the things I want you to start thinking about, and I want you to write in your notes. So if it's 2 minutes, if it's the heart rate, you can say it started out real high. You know, let's talk about 180 instead of 18. So you can make up your numbers whatever you want, right? Now 200 is when your heart starts to want to explode. So anything above 200, you're either really fit or your heart's going way too fast, right? And so if your heart was going way that fast when you checked it, that means, okay, I need to sit down, calm down, and as I calm down, I was able, okay, now I can start working out again. Because if you're working out and you hit that level of 200, you do not want to keep going. You want to bring it down to the 160, 120 range, okay? Now, if I was going to a friend's house, I like to think about it like that, because here I'm heading towards his house would actually be going down, right? Because we're going away from my house, right? So, but here we're going away from his house. So I kind of have to go around something. Now here's a certain speed. Maybe I'm walking. Here I'm running. Maybe here I took the bus. So I went really fast, right? Then I got off the bus and I started walking parallel to his house. I didn't get any closer. I didn't get farther away. Or I sat there and waited until somebody met me, and then I started walking towards his house. And then we ran away because the dog came out. Then we walked towards, then walked away. Ran around somebody's house because they came out and chased us, right? Or we just wanted to run for whatever reason, right? Because we're kids. Okay? And then we're walking really slow, going parallel again to his house, making sure you're telling me, are we going closer or farther away from the house? Are we going at a faster pace or slower pace? You need to be able to understand that the bigger the slope, the faster the pace. Does that make sense? Okay? And I need to hear these stories. I don't care what they are. You just got to make them up yourself, okay? And I want to know that you understand this function. Oh, by the way, this is a function. Why is it a function? None of the x's came up twice. You notice that the y's came up twice a lot? That happens in a function. But the x's cannot come up twice. If it does, it's not a function. If anything goes straight up and down, it's not a function. Okay? All right. There you go. Have fun.